In optics, it can be quite useful when we are working with gratings to have an idea of how the different diffraction orders behave. To do this, there is a diffraction tool that is designed to display how the diffraction orders of a specific grating look like in terms of their direction. When we open this tool, we have on the left all the controls, as usual, and here's the 3D view that display how these diffracted orders are directed. In this case, my grating is a square grating. This is done through the control of the angles of the grating vectors, and it has a grating width or period of 1 micron. I'm here displaying the case when the incident wavelength is 500 nanometers, but if I wanted to look at 200 nanometers, for instance, we would see a lot of different diffracted orders. In this case, the substrate is still 1.0, so I'm going to set it to 1.5, for instance. And we see an increased number of rays because, of course, higher refractive indexes are going to diffract more. So I'm going to switch back to 800 nanometers, for instance. We can control the angle of incidence over there, and we see how the different diffracted orders rotate depending on it, and we can change the azimuth of the incident ray. The incident ray is represented by the green ray over here. We can change, of course, the angle between the different grating vectors. For instance, if I wanted to have an hexagonal grating, I would set this to 60, and we, in this case, have an hexagonal grating, and we can see the hexagonal symmetry of this structure. So this is, in the case we want to visualize the monochromatic response of the grating. There is a way to count the number of diffraction orders in the polychromatic mode. In this mode, we select the full spectrum, so in this case it's in the visible range, and this graph displays the number of orders that are present in the grating response depending on the wavelength. And we can see in this case, since the periodicity is 1 micron, we still have diffracted orders at 850. So if I change this to 165, for instance, we have over here grating the diffraction order number of 1 because we only have specular reflection and direct transmission. And as the wavelength decreases, we first see appearing new diffraction order in the substrate and then in the superstrate.